All right, so now we'll go into a little bit more of the application as far as physics. We're going to be looking at displacement, velocity, acceleration, and hopefully making a little bit of sense of that. Obviously, those who have had physics already have a little bit of an advantage here because they know some of the relationships between these, and they've already talked about some of the conceptual ideas between the relationships. However, a lot of this is still going to be new for them as well. So don't feel too much at a disadvantage. It's just one little thing that we've got to get over before we're ready to be able to answer questions about these. Okay, so the first thing we need to talk about with displacement is that displacement is shown with S of t. Okay, I really have no idea why they use an S, but they do. Now, we need to understand that displacement is a vector. Okay, so what does that mean? Well, most of you know, because of Despicable Me, that vector has direction and magnitude. And so therefore, you need to have both the direction and the number which describes the magnitude. Now, in this course, when we do these derivative applications, we are going to be looking in one dimension only, which means we'll be going up and down or side to side. We're not going to be doing anything like projectile motion that's going up and down and to the side all at the same time, because that requires being able to take the derivative of both the x direction and the y direction at the same time, which we're not quite ready for. So we're just going to go ahead and look in one dimension. So when we talk about something moving side to side, going to the right will be positive, just like it always is, and going to the left will be negative, just like it always is. Up will be positive, down will be negative. Okay? So that's the basic idea behind displacement being a vector. Now, often when we talk about displacement, we're actually talking more about your position, right? What is your position relative to the origin? So if I state that my displacement is 5, unless I have some other starting point, the assumption is that the starting point is 0, 0 is the origin. So if my displacement is 5, that means that I am 5 spaces away in the positive direction from the origin, which means I'm at 5, 0 if I were on a coordinate plane. Now, velocity, as we talked about at the beginning of the last video, velocity is a change in displacement, a change in distance, a change in position. All right, so we show this with a v, of course. So v of t is usually showing our velocity. Now, because of this, we can go forth and talk about this a little bit more. Let's do average velocity first, which is what I did in the last video. Average velocity, which you can show with a bar if you want. Remember, bar is average. And so the average velocity is a change in displacement over a change in time. Now, it does have to be displacement, not distance, because velocity only takes into consideration your initial and final points if we're looking at the average. And so you talk about your displacement. How is my final position different from my initial position? And then you divide it by the amount of time that has passed during your measurements. All right, so then we go on and we say, okay, well, how do we get instantaneous velocity? Well, instantaneous velocity is going to be related to this, except instead of finding it over a finite period from time 1 to time 7, we're finding it at a specific instant, right? Now, you could imagine that if I had a graph that was time and position, that as my position changed, something like this, the velocity is the change in position over the change in time. So that would be a change in position over a change in time. So that would be my delta S. This would be my delta T, which is why that gives me the average, right? It's halfway in between. However, if I bring these 2 points together, so rather than looking at this finite difference, I'm looking at a specific point. We've talked about that before, bringing this point closer and closer and closer. We are now looking at a derivative, which instead of delta S with the capital triangle delta, it's now going to be ds over dt, which of course is the same thing as s prime. That gives us instantaneous velocity. One other thing that we need to make sure of is that we understand that a positive velocity means that the displacement is changing in the positive direction. So if I have a number line, which direction is positive? Well, if this is the positive direction, a positive velocity always means that I'm moving in that direction. It doesn't matter where I am, it means that I'm moving in the positive direction. Okay? That would be both the average or instantaneous velocity. A positive means I'm moving in the right direction. A negative velocity always means that I'm moving to the left direction, in the left direction, all right? Now we'll talk about acceleration. Well, just like velocity was the change in displacement over the change in time, acceleration is going to be the change in velocity. Okay, so acceleration is talking about how is velocity changing. Now, in this day and age, we tend to talk about acceleration when we're speeding up. But slowing down is also acceleration, because acceleration is a change in velocity over a change in time. Now, an interesting thing that we didn't talk about in class that isn't really necessary to this course, but since velocity has direction, that means that when you change direction, you are accelerating. Even if you're not changing your speed, that is still considered acceleration, because acceleration is defined as a change in velocity, and velocity is direction and magnitude. So if the direction is changing, your velocity is changing, therefore you are accelerating. Pretty snazzy, huh? All right, how do we get average acceleration? Well, very similar to the way that we did the average velocity. So average acceleration would be the change in velocity over the change in time. Again, where we have a finite change. So we're looking at that change from time 1 to time 2. Now the next question, of course, is how do I get instantaneous acceleration? Well, it's pretty much the same thing as before. Acceleration is going to be the change in velocity, so it's going to be an infinitely small change now. We're looking at a specific instant, which of course is the same thing as v prime. And since v was s prime, this is the same thing as s double prime. We take the derivative once, we get the velocity. We take the derivative again, we get acceleration. All right, so that's pretty much everything. Now, acceleration is a little bit hard to put together with the others, and so we're going to look a little bit more at that. Okay, but first let's go ahead and we'll work through a problem, and then we'll go ahead and we'll look at some more of the details of how these things are related. All right, so here we go. When a ball is thrown, its height above the ground is given by 1.2 plus 28.1 t minus 4.9 t squared meters, where t is the time in seconds. From what distance above the ground was the ball released? Okay, well, when the ball was released, time is 0. And so we can go through, we can make this t0, make that t0, which means the only thing left is st equals 1.2. So it was 1.2 meters up in the air when it was released. All right, now find s prime of t and state what it represents. So if we take the derivative, okay, I take the derivative of this part. Remember, the pluses and minuses mean I can do these pieces individually. And so 1.2 is a constant, it's going to go away. So s prime of t equals, and then this has a 1, so I'll bring it in front, making it 28.1. Then the variable goes away, minus, and then this 2 will come in front, which will be 9.8 t. And so this expression now represents the derivative of the displacement, which of course is velocity. And not just velocity, but since it's the derivative, it is the instantaneous velocity. All right, now we go find t when s of t is 0. So we plug in 0. So we go 0 equals 28.1 minus 9.8 t. And again, like on the last slides, I'm not going to work these out. I'm just going to show you how it's set up because you can do the algebra. So when you get t, that's the t at which s prime is 0. Remember, s prime is the velocity. So if the velocity is 0, what does that mean? Well, number 1, it means that it's not moving for that instant. Okay, number 2, it means that it's changing direction most likely. Okay, because when the velocity is 0, that is a turning point. most of the time when you have a velocity of 0, it's changing from one direction to the other, and so it's passing from a positive to a negative velocity or negative to a positive, which is why it's going through that 0 value. And so when it goes through that 0 value, that's when it's changing its direction. Remember, the plus and minus of a velocity just represents the direction. So if you change from a positive velocity to a negative velocity, you're automatically changing directions. That's what the plus minus means. All right? Then it asks for the maximum height. Okay, well, if you think about this as a quadratic graph, right? We know that we have a y-intercept of 1.2, and then we know that it's a quadratic and that there is a negative in front of the quadratic, which means that it's going to have to look something like this. So the maximum needs to happen up here. What is the derivative up at the top? Well, hopefully by this point you figured out that the derivative up at the top at a maximum or minimum is flat. It's 0. And so when I make s of t 0, I can find the maximum, which means therefore when I put the 0 in and solve for t, now I can take that t right here and I can plug it into the original function, which will tell me the displacement for time d, the highest point, because that's the time when the highest point occurs when the derivative is 0. Therefore, it will give me the height. All right? So then we go into find the ball's speed when released. So when released, time is 0. This is talking about speed, except I just don't need the direction, right? So I can put in 0. If I get a negative number, it doesn't matter. Negative 5 meters per second in terms of speed just means 5 meters per second. The direction doesn't matter. So I'll plug in 0, time equals 0 to get the time or speed when it's released. I'll plug in 2 for t here to find out how fast it was going after 2 seconds. And then I'll plug in 5 for t to find out how fast it's going after 5 seconds. All right, he's checked off. The significance of the sign, again, remember that's just the direction. The sign is just the direction of the velocity. It's telling you which way the velocity is. Okay? Letter F, how long will it take for the ball to hit the ground? Okay, well, when does it hit the ground? Hits the ground when the displacement is 0, right? This is height above ground. So when the height above ground is 0, then you should be able to solve the quadratic. I highly recommend using a calculator and just finding the zeros using your graphing calculator function. Okay? Then it asks for the significance of the second derivative. Okay, well, we just talked about that in the previous set of slides. S prime of t is the velocity, and then s double prime of t is the derivative of velocity, which is a change in velocity, which therefore is then, by definition, the acceleration. All right? So let's go a little bit farther, and you can try this on your own at home. I will give you the answers as we go, but hopefully you'll be able to figure these out where you should be and such. So here we go. We'll go through a couple of these, and then I'll stop the video and we'll go for another one. So, assuming that all motion is in a straight line to the right or left, describe each of the following situations with as much detail as possible. If possible, include where is the object. Okay, if you want to move around at home, you can. If you just want to draw this on your paper, it's fine too. But where is the object in relation to the origin? What direction is the object traveling? Is it moving right or is it moving left? Okay, if you need to pause this to read through all the rules of the kinesthetic moving activity, then go ahead. Is it speeding up or slowing down? And that is it. So where is it? What direction is it going? Is it speeding up or slowing down? So here we go. Assume, there's the questions again. This is the information given to me. What does this tell me? Well, it tells me that my position is at 0. Does this tell me anything about the speed? No. Does it tell me anything about the acceleration? No. Therefore, I don't know which direction it's going. I don't know if it's speeding up or slowing down. All I know is that right now, it is at 0. All right? Let's try another one. S of t is positive. S prime of t is negative. Okay, so let's look at this first. What does this mean? This is displacement. So it's saying that the displacement is positive. So if the displacement is positive, That means if 0 is here, I am somewhere over here. That's all it tells me. It doesn't tell me about speed, direction, anything else. Now I know that s prime of t, which is velocity, is negative. So if the velocity is negative, that means that I am traveling in the negative direction. So that means I'm going this direction. I don't know if I'm speeding up or slowing down. All I know is that right now I'm over here and I am traveling to the left. All right, next up. If you want, after you read pause it as soon as you get to this slide so that you can then work through it on your own and then listen to my explanations. All right, so here it says s prime of t equals 0. What is that telling me? Well, s prime of t is the velocity. So velocity equals 0. Now, what does that tell me? Well, does it tell me where I am? No, it doesn't, does it? All it tells me is that I am stationary. Okay? It doesn't even tell me if I'm speeding up or slowing down, because I could be speeding up and just at this moment I'm going 0. I could be slowing down and at this moment I'm 0. Let me give you an example. When a ball is thrown up in the air, what happens as it gets closer and closer to the top? It slows down, it slows down, it slows down, and then once it gets to the top, at the top, its velocity, if you're throwing it straight up in the air, its velocity is 0 for that instant. However, it's still speeding up there, and now, or sorry, it was slowing down as it goes up, and it was speeding up as it goes down. There's no way of knowing whether it's speeding up or slowing down at that point in time. Or, I guess it can't be slowing down. It's already going 0. But you can't tell whether it's completely stationary and staying stationary, or if it is at 0, however, at this point it's speeding up. Okay, so let's go ahead and look at one more, maybe two more. I just heard the bell, so I'm going to have to go soon. So here we go, s of t is 0, so that means something about the position. So that means I am here at 0. S prime of t is positive, that is velocity. If velocity is positive, that means I'm moving to the right. Now, s double prime of t is also positive. Now, if the velocity is positive, that means I'm moving to the right. If the acceleration is positive, that means it's becoming more positive. So if it's positive now and becoming more positive, that means that I am speeding up. Right? Okay. One more, maybe two more, maybe two more. Let's see what we can do. So here we go. S of t is negative. Everything's negative. So s of t being negative just means that I'm over to the left. Doesn't mean anything else. S prime of t, that's the velocity. And a negative velocity means that I am moving to the left. Okay, now here's where some people get confused, because now it says that the acceleration, s double prime of t, acceleration is negative. Now, that means that my velocity is becoming more negative. Well, if it's already negative and becoming more negative, they're going in the same direction. Therefore, it is speeding up. If it's asking about velocity, yes, the velocity is becoming more and more negative, which means it's decreasing as far as the numbers go. But if it's asking speeding up or slowing down, the magnitude is becoming greater and greater. It's just more and more negative. Therefore, it is speeding up. Okay, last one, because I want you to see this one. This one doesn't tell us where we are. We have no idea where we are. All we know is that we're moving to the left and that the acceleration is causing us to become more and more positive. Because the acceleration is pushing against the velocity, that now means that I am slowing down. All right, so I think that's enough for now. I will put up another video soon, hopefully with a little bit more application for you.